Hello, and welcome to this video where we are going to go over how to calculate the distance between 2 points. Or you can also say how we're going to calculate the length of a line. Okay, so in the last video, we were calculating the length of a line, and let me just see if I can bring that up. So this is what we did in the last video. And you can see that the lines are perfectly horizontal, which means they go across. They go across like this one, or they go straight up vertically like this one. So all you need to do when you've got a horizontal line or a vertical line is, like we learned in the last video, you just count. You count the number of boxes that it goes across, and that's what we did here. So for example, with E and F, you count the number of boxes between E and F. So there's 1, 2, 3, 4, 5, 6, 7. So the distance between E and F is 7 units. And these are the sums we did for homework last week. And over here between G and H, we have 1, 2, 3, 4, and 5. 5 boxes between G and H, so it's 5 units. But what happens if the lines are not perfectly straight across? So what happens if they're not perfectly horizontal? What happens if they're at an angle, like these lines? So if we look here at this yellow line, this one here, how am I supposed to find the length of this line, or the distance between these 2 points? Let's just call this point A and this point B. How am I supposed to find the distance between A and B? Because if we look, we can't count the boxes because it cuts across the boxes unevenly. So it's not a simple job of counting how many boxes it cuts through, because that wouldn't give us the correct answer. So what we're going to do is we are going to use a theorem that we learned about 2 weeks ago, which is Pythagoras Theorem. Now, all of these lines, they are hypotenuses, which is sounds very difficult to say like that, but they are the hypotenuse of a triangle that just hasn't been drawn yet. So all I have to do with the line A and B, the first thing I do is I draw a line down, and then I draw a line across, and I create a triangle. And you can see now we have a triangle, and we can count how long this side is from here to here. It's 1, 2, 3 boxes, all right? And we can count how long the bottom of the triangle is. It's 1, 2, 3, and 4. So if you remember Pythagoras' theorem, it's a squared plus b squared equals c squared. Now, in this case, C is the hypotenuse, and that is the length of the yellow line. And A is this side here, and then B is this side down here. So we figured out that A was 3 boxes long. 1, 2, 3. So we write 3 squared. Plus, now B squared, we counted 1, 2, 3, 4. Let me just readjust this. Sorry about that. So we counted that the bottom is 4 squares wide, so we write 4 squared. Okay, and we don't know what the yellow line is yet, but hopefully you remember Pythagoras' theorem. So 3 squared is 3 multiplied by 3, which is 9. And then 4 squared is 4 multiplied by 4, which is 16. And that equals c squared. So 9 plus 16 is 25, which equals c squared. And remember, we want to get rid of the c squared so it becomes a c. So we square root both sides. And this square root cancels with this one. So now we just figure out what the square root of 25 is, and it's 5. So we have figured out that the length of the yellow line, AB, the length of AB is 5. So we're using Pythagoras' theorem to figure out the length of a line. And the only thing we have to do at the start is we have to find the triangle. So I'm going to do the brown line now on the bottom left corner. So the first thing I'm going to do is I'm going to draw a triangle. So I draw a line down like this, and then I draw a line across like this. And now I have a triangle, don't I? And I count how long this side is here on the left-hand side. It's 1, 2, 3. So the left-hand side is 3. And the bottom of the triangle is 1, 2, 3, 4, 5. So the bottom is 5. So now all we need to do is use Pythagoras' theorem to figure out the length of the brown line. So again, a squared plus b squared equals c squared. So we have a squared, which is 3. So 3 squared plus b squared, which is 5 squared, equals c squared. So 3 squared is 9, and 5 squared is 25. And that equals to c squared. 9 plus 25 is 34, equals c squared. Now, we want to square root both sides. Square root both sides. This square root and this squared, they cancel because they are opposites. So the square root of 34 equals c. Now, if we go to our calculators on our phones and we tap in the square root of 34, we'll get 5.83. But if you remember, we can leave it like this, or we can make it into a decimal if it's not a very clean square root. So this one here was very clean because it makes a perfect number. It makes a whole number. But down here, this square root, you can see that the answer is a decimal. So you can leave it either as a square root or you can have it as a decimal. So the length of the line down here, the brown line, is the square root of 34 or 5.83. So for homework, I'd like you to try and figure out and I'm just getting a different color here. I'd like you to try and figure out the distance between the orange line, which I'm just drawing now, the orange line. So we want to find the distance between the 2 points on the orange line, this point here and this point here. We want to find the length of this orange line, and we also want to find the length of this bluey green line, this turquoise line. Just remember that when you're doing these, what you have to do is you have to draw a triangle, okay? I'm going to do this one for you here. So you draw a line out and you draw a line down until you have a triangle, and then you count each side and you use Pythagoras' theorem. I'll let you do the orange one all by yourself. If you have any questions, just send me an email or leave a comment on Google Classroom.